Okay, now today on this particular video, it's kind of going to be a collection of some things that we haven't covered yet that kind of deal with measurement and with area, because next week we're going to go to three-dimensional shapes. So we're going to finish up with this video kind of our two-dimensional figures and some things that we need to kind of clean up and double check about those, okay? So the first thing I'm going to do is kind of finish up the area and kind of start with circle area and what we call sector area, which is part of a circle, okay? But I know that you already know the formula for the area of a circle, but you might not know where it comes from. And you know, when you start teaching, sometimes those kids are going to ask you why. So I want to make sure that you understand why. All right, so let's go get the PowerPoint like we usual. Okay, put that on the screen so you can kind of follow it. So what we're going to end up doing is we're going to do circle area and sector area first, and then I want to kind of jump back and kind of go back to the outside of two-dimensional shapes and make sure that we're clear on measurement and then kind of triangle side lengths, particularly Pythagorean Theorem. Okay, so here's the formula for the area of a circle, which I know you already know. The area of a circle is pi r squared. Now remember, the circumference of the circle is just pi times d, okay? So the outside of a circle is pi times d, and the inside of a circle is pi r squared. So I know you know that, but let me kind of show you where it comes from. All right, it basically kind of tells you you're really transforming basically a circle into kind of a crude parallelogram. So here's what happens. I've cut this circle into a bunch of congruent triangles. Now, if you count, there are basically 16 of these, I believe, all the way around, all right? Now, look what happens. If you were to cut here and then lay it out, you would kind of get this shape. When you did, you'd get 16 triangles all across the top, okay? And then what they did was they took half those triangles and kind of put them on the top and half of the triangles on the bottom to kind of give you a crude parallelogram. So there are actually 16 of them, but look across the bottom, there's only 1, 2, 3, 4, 5, 6, 7, 8. So there's only 8 of them across the bottom length. So do you see that that would be half of that circumference? Because I've got half the triangles down here, and then I cut them and put half the triangles up there. So if you cut that and lay it out, you just get like 16 triangles that look like teeth, okay? So we folded half to make this shape. So that's why there's not, down here, there's not a 2 pi r. There's only a 1 pi r because half of them are down here and kind of half of them are up there. So this length right here would be half of your circumference. And half of 2 pi r is 1 pi r. And then, of course, this would be the height, which is just r. So remember, how do you find the area of a rectangle? Well, you do base times height. So if you do pi r times an r, that's where you get the pi r squared. So that's where that formula for the area of a circle comes from. Now, do you have to do that for me in a test? No. You just got to be able to use this formula. All right, so let's just go look at a couple of examples quickly. Okay, because I know you already know how to do this, but it makes me feel better. So remember what we talked about. If you want to know the circumference of the circle, it's pi times d. So if you want to know circumference, you need to know the diameter. Radius is what you need to know with the area of the circle, because that formula is pi r squared. Okay, so it kind of reminds you need the radius. All right, so look here, you've got a radius and a diameter. So if the radius is 9, then all you need to do is square your 9. Okay, so that 9 goes in place. Now, I'm going to make sure we're clear about something. With me, if you change from pi to 3 1400ths, I do not want an equals. Okay, remember what I'm going to want. As soon as you put that decimal approximation, you're going to have to change to approximately equal for me. Now, if you want to leave it pi, you're welcome to. Okay, but remember, order of operations. Exponents come before multiplication. So 9 squared is 81. So you could say that it equals 81 pi All right. But again, make sure that you put your square inches on there. Or you could say it approximately equals 254 3/10 square inches. All right, so you can leave it exact 81 pi, or you can put that decimal approximation in there. But if you do, remember, I don't want equals like this person did. I want approximately equal to with decimal approximations. So that would be your choice, exact answers or decimal approximations. With elementary students, decimal approximations really do communicate better to them. This symbol pi is pretty abstract if you're 10 years old. Okay, so now look over here. My formula is still pi r squared, but do you understand why there's not a 5 in there? Because 5 is all the way across, so it's the diameter. So you'd have to half that in order to get the radius. And so half of 5 is where they got 2 5/10. So remember, you square before you multiply. Exponents come before multiplication. So if you square 2 5/10, you get that 6 25/100. And then again, as soon as you put that decimal approximation in there, you would turn it into approximately equal to. Okay, so I would need approximately equal to, not equal to. And then I want to make sure I kind of did this on purpose. Do you see how they left their units off? If you were to leave your units off, I'd count points off. So I would want approximately equal to 9 625 square yards, or you could say it's exactly equal to 6 25/100 pi square yards. Kind of your choice. Okay, now I'm not going to take time to work this next one, but do understand some books, maybe a praxis test sometime, instead of using 3 1400, sometimes they use the fraction 22/7 for pi. So do understand that's a decimal, instead of a decimal approximation for pi, that ends up being a fractional approximation for pi. Now, sector area is part of the whole area, okay? So just like with arc length was part of the whole circumference, sector area is part of the whole area. And you do it the same way. Your part is going to be your angle measure over 360, and then there's your whole area, okay? So they say find the area of the sector of a circle with a radius of 6 centimeters if the angle of the sector is 60 degrees. So we put that 60 over that 360, because that's what the formula has. There's our pi. Our radius is 6. Now remember, order of operations. We don't have anything inside of a parenthesis to do, so the next thing we look for is exponents. So you would square that 6 and get 36. And then we reduce this fraction to get 1/6. Remember, single things go over 1, okay? So that's kind of, I'm gonna erase these marks so that's not bothering you, okay? So single things go over 1, and then you go straight across the top, 36 pi, straight across the bottom, 6. And then of course that's exactly 6 pi, but again, if it's any kind of area, it's square units. If you'd rather go to approximately equal to, you can substitute that 3 1400 for pi, and get 18 8400 square centimeters. So on a test, I expect you to have exactly equal to or approximately equal to, your choice. Now I did want to show you this one. I used 22/7 instead of using the 3 1400. Now remember that 36, you could put 36 over that 1, okay? And then you're going to go straight across the top and straight across the bottom. And when you do that and you reduce it, you get 132 divided by 7 square centimeters. But you could change that into a mixed number, okay? So either way is fine with me. Now that kind of finishes our area, okay? So I do want to make sure that you've kind of got all your formulas now for area that you're going to need to know for your test. You've got areas of parallelograms, which includes rectangles and squares. You've got areas of triangles. You've got areas of trapezoids, okay? You've got areas of regular polygons, that 1/2 AP. All right, if it's irregular, if it's a shape you don't know the formula for on a polygon, just divide it into shapes that you do know formulas for, and then find the area of each piece and add them up. Now you've got area of a circle and part of the area of a circle called sector area. So that's all the area formulas that you're going to need for your test, okay, which will be at the end of the month. Now, I do want to kind of backtrack for a minute. I don't want to make any assumptions. You know, we talk about all the time in class what happens when we assume. All right, I do want to go back and double check because you're going to have to do outside. And I'm assuming you know how to measure with a ruler, but I don't want to make an assumption because you're going to have to teach it. Now, there's a difference between measuring with an English ruler and measuring with a metric ruler, okay? So I want you to notice if you were to start counting like 1, 2, 3, 4, there are 16 little tick marks. So there's 16 between 0 and 1 and 16 between 1 and 2. So it divides each inch into 16 little congruent pieces, okay? So I want you to notice something. Okay, do you see this kind of gray looking segment up here? All right, do you see it goes from 0 to 4, so it's 4 whole ones, and then when you start counting, it's going to be 8 little tick marks when you get right there. So that segment ends right there. So it's going to be 4 whole plus 8, and then remember that bottom tells you how many equally sized pieces make a whole. And then on English ruler, there are 16 pieces. So that's why it's 8 over 16. And when you reduce that, you get 1/2. So that's 4.5 inches. Now, you're fine if you can go to decimals if it's exact. But don't give me a decimal approximation unless I give you specific permission to do that. But notice, it's not 4.8, it's 4.5. So I don't want you to think that when if you go to 4 and you go 8 little tick marks, it's not 4.8. You have to put that how many tick marks over 16. Now again, we talked about that the metric system's way easier than the English system. So let me show you what I mean by that. On the metric system, what happens is, again, remember the number you need to know is 10. So instead of dividing each little thing by 16 units, they do divide it into 10 units, okay? So if you were to count here between every integer, there are 10. So here, if you count, this goes all the way to 7, and then that's on the 9th tick mark. Well, look, 9 over 10. Now, why 10? Because there are 10 equally sized pieces between each integer. So when you're 9 tick marks past 7 on a metric ruler, you are 7.9, 7 9/10. So again, everything's easier in the metric system. So just make sure that this is how many tick marks you are past a whole number. But on the metric system, there's a 10 as a denominator. On the English system, there's a 16 as a denominator. So make sure you get that clear. Now, again, I want to make sure we talk about something called the triangle inequality theorem. It's in your book. Now, this goes with all triangles. All right, here's what it says. On all triangles, the sum of every 2 sides must be greater than the remaining third side. Okay? So sometimes in your book, they're going to give you 3 measurements and ask you, could you make a triangle using this? Well, the way you've got to check is you've got to add every 2 and make sure it's bigger than the one that's left. So 9 plus 16 is 15, and sure enough, 15 is bigger than the one that's left, the 3. But you don't just do it with one, you got to do it with all the pairs. Then maybe 9 and 3. Now 9 and 3 is 12, and 12 is bigger than the one that's left on 6. But look what happens. When you add 6 and 3, you get 9, but 9's not bigger than the one that's left. So you could not make a triangle. If you had a segment that was this long and a segment that was this long and a segment that was this long and you put them together, it wouldn't make a triangle. But now if you had 3 inches, 4 inches, and 5 inches, 3 plus 4 is 7, and 7's bigger than 5. 4 plus 5 is 9, and it's bigger than the 3 that's left. And then 3 inches plus 5 inches is 8 inches, and that's bigger than the 4 inches that's left. So here, these would form a triangle. So they give you 3 lengths. You add every 2 and make sure it's bigger, not greater than or equal to, but greater than the one that's left. And that's how you know if those 3 lengths will form a triangle or not. Now again, I'm going over some things I think you already know, so I'm kind of going over them pretty fast. Again, I know you know Pythagorean Theorem, but I want to make sure we kind of understand what that Pythagorean Theorem's saying, okay? So look at this. Most of you know Pythagorean Theorem as a squared plus b squared c squared. Now, I would not necessarily give that to kids at first. I would say that a leg squared plus a leg squared equals the hypotenuse squared, okay? Because they could label C as one of the legs, and then A squared plus B squared equals C squared would not be correct. Now, that triangle inequality theorem works for all triangles, but the Pythagorean theorem only works for right triangles. See, right triangles, okay? Now, the hypotenuse is easy to find. That hypotenuse is always directly across from the right angle. So the other two sides are called legs. So if you take this leg and you square it, and you take that leg and you square it, and you add those two answers, you're going to get exactly this side squared. So look what it says in geometry kind of is a shape. You know, A squared means you literally have a square that's A long and A wide. Okay? B squared would mean you had a square that was B long and B wide. And then C squared would be a square that's C long and C wide. So what would happen is, if I could move that rectangle and put it here, and I could cut this one up and fill in the space, this green area plus this blue area would be exactly the same as that pink area. So a better way to teach people the Pythagorean theorem is that a leg squared plus a leg squared equals the hypotenuse squared. And remember, the hypotenuse is the side across from the right angle. So look what we call it. Some people call it Pythagoras theorem. Most books will call it Pythagorean theorem. That's what I'm going to call it. Okay, so notice you've got to find the hypotenuse. So how do you find the hypotenuse? Well, it's directly across from that right angle. See, this hypotenuse is going to be directly across from that right angle. So these have to be your legs. So see, a leg squared plus a leg squared equals your hypotenuse squared. Well, 3 squared is 9, and 4 squared is 16. So I know that x squared, okay, would equal 16 plus 9, which is going to give me my 25. Okay? Does everybody understand? So that's kind of probably, I would go from here to here. And then remember what happens. What number can you square and get 25? Well, now here's what I would want you to tell me. I would want you to tell me that actually it's not the square root of 25, it's a positive or a negative square root of 25. Because you ended up getting a positive or a negative 5. Because remember, what's 5 times 5? 25. What's negative 5 times negative 5? Positive 25. So x could actually be 5 or negative 5. Now, why did they leave off the negative? Well, because it's a length. And lengths can't be negative. Okay? So that's why they ended up saying that it was only a positive 5 centimeters, because it's a length. All right, again, here, the side across from my right angle is my hypotenuse. So 5 squared plus 12 squared equals x squared. All right, so that's going to give me that x squared, okay, is actually going to equal, now if you add 25 to 144, that's where you get that 169. Okay, so x squared's got to be 169. So remember what we do. We take the square root of both sides. But on your test, I would want to see a positive or negative here. All right, so really mathematically, you get a positive 13 or a negative 13 centimeters. But the way you know it's got to be positive because it's a length, and a length can't be negative. Okay, now these two examples, you're trying to find the missing hypotenuse, but actually sometimes you're going to be missing a leg. So let's make sure we're okay on that. Now remember what we know. We know that the hypotenuse is the side directly across from the right angle. So this time, my hypotenuse isn't x, my hypotenuse is 20. So x is a leg, so a leg squared, 14 is another leg, so a leg squared equals my hypotenuse squared. So x squared, when you 14 times 14 is 196 is 400. Now remember what we're doing. We want to isolate our variable. How do you undo addition? That's right. To undo addition, you subtract. Addition and subtraction are inverse operations. They undo each other. So I subtracted 196 from both sides, and that's where I got the 204. So again, look what we did. Okay. We have x squared is 204, so x is a positive or negative 204. Now we learned to do this, remember, in Math 210. 204, if you do a factor tree, is 4 times 51. And so remember, it's 2 times 2 times 51. So I pulled out one of those pairs of 2's. So I either get a positive 2 times the square root of 51 or a negative 2. All right, but remember, it's a length, so it's got to be positive. Now again, if you'd rather give me a decimal approximation, you change to approximately equal to. And if this had units on it like inches, I would expect to see inches down here. Okay, so this video is kind of a collection of some different kinds of topics. So again, you're going to have homework on Moodle. All right, so make sure that you go try that. If you need some help, make sure you contact me and let me know. Okay, I hope you're doing great. All right, like I said, I still miss you. Okay, so if you need me, you know how to get in touch with me. All right, hope you have a great day.